Lecture 3, short run cost. Again, we have the short runs, so we have one fixed input, which is capital, and the other input we have is labor, and that's going to be the variable input. Which means we have variable cost and we have fixed cost. So variable cost is, use VC for that, and these are the costs that vary with the level of output, which is why it's called variable cost. In the real world, this would be labor, raw materials, energy. So if you run a restaurant, this would be staffing cost, cost of your food, produce, meat, beer, wine, the cost of using energy, utilities, gas, electricity, water usage. All that represent our variable cost. And so the more customers we have, the more meals that are ordered, then our costs are going to go up. In our simple world of Chapter 7, we're going to have just labor. Use L for labor. And so the variable cost would be the wage, which if it's a competitive market is set by the market, times how many workers we hire, L. Please note that even though I said variable cost is equal to wage times labor, there are many different ways to determine variable cost on a test. We have 7 cost data variables to collect, and if you know many of those, you can also figure out the other ones as well. Now, whenever we have a total and variable cost is a total, you have an average, and an average would be the variable cost divided by output, and this would be the variable cost per unit of output. So very simply, if your variable cost is $10,000 and we're producing 100 of something, then what's the average variable cost? We would take $10,000, divide that by the 100. Maybe we're making chairs again. Then 10,000 divided by 100 will give us $100 per chair. So every one of those chairs would have $100 of variable cost in it. Then if we know the average variable cost and the output, we can figure out the variable cost is. Work backwards. So if we're making 1,000 units and each one costs us 4 on average, that's how many $4? That's 1,000. So then your variable cost would be 4,000. On average, each of them costs $4 of variable cost. I have 1,000 of them. Each one is $4. $4 times 1,000, $4,000. Average variable cost is going to fall at first, hit a minimum point, and then will increase as well. The other costs are fixed, and they're called fixed because they're fixed. They do not vary with output. If you talk to people in business, this would be what they would call their overhead. So any kind of construction cost, if you had to pay for a factory or warehouse, is fixed. Once you pay for the warehouse, you can't change that. The lease agreements, you sign a lease agreement for a year, you can't change that for the year. Property taxes, again, has to be paid, no matter what you do with the property. Regular maintenance, even if you don't use it, you have to maintain your property, your equipment, your structures. Insurance premiums, all that is overhead. And whether you produce one more chair, these things don't change. If one more person comes into our restaurant and sits down for dinner, these things don't change. The maintenance of the restaurant doesn't change. I still got to pay the same property tax. If I sign a lease for the property, I can't change that. Insurance is going to be the same. None of these things change when one more customer walks in the door. So your fixed cost, simply think of that as your capital cost. Make it simple, just call it one thing. And then your average fixed cost would be fixed cost divided by output. And unlike average variable cost, and we'll see average total cost, average fixed cost just falls. And people in business who have high fixed costs, they understand this concept very well. They live and die by the volume of their output. They have huge fixed cost. If you're in the airline business, most of your costs are fixed. You have to pay for the aircraft up front. You have to pay for the gates at all the airports. Most of your staffing, your pilots are salary staff. They're fixed. You have insurance cost. You have loans. All of that is a fixed cost. their variable costs are very low. You walk in an airplane to fly from here to New York City, you cost them a bit more in fuel and a couple of bags of peanuts, and that's it. So they live and die by how many passengers they can send from point A to point B, which is why the planes are packed as much as possible, because they have huge fixed costs to try to get that money back. By increasing their output as much as possible. And again, your average fixed cost is fixed cost divided by output. And so if we have 1 unit of output, the fixed cost of $1 million, if $1 million divided by 1, your average fixed cost is $1 million. If I can increase output to 10, I can cut that all the way down from 1 million down to 100,000. I get 100 units of output, I can cut this down to 10,000. I get 1,000, I can cut my $1 million fixed cost down to an average fixed cost of 1,000. So the more I can increase my output, the more I can spread that fixed cost over more and more output, which drives down my average fixed cost, which is also going to drive down my average total cost. Total cost is going to be your total cost. It's variable and fixed. Average total cost, you take your total cost divided by output, or you can add just the two averages together. It would be the same thing. It may come off as being different numerically because you may have rounded here, one of these two numbers, in which case it'd be off a little bit sometimes, but theoretically, they're the same thing. Average total cost will fall at first, hit a minimum, and then also increase. Average total cost is useful because I can compare my average total cost with my price and know right away whether I am making positive, negative profit, or breaking even with normal profit. So let's say I know on the test that my average total cost, say, is $11. And let's say I'm selling things at, say, $9. Well, I have a loss of $2 per unit real fast. I know I have an economic loss. So if my price is below my average total cost, I have a loss. If my price is above, I have a positive profit. And if my price is equal to $11, then I would have zero economic profit. The last data variable we want to keep track of for our cost is marginal cost. And this tells us the increase. Total cost always goes up and variable cost always goes up. So it tells us the increase in total cost and variable costs when one more unit of output is produced. Why both? Well, because the only cost that increases is variable. Total costs and variable costs go up by the same amount each time. Total cost is only separated from variable by fixed. But that's a constant, right? So if this one is fixed and doesn't go up, if this goes up by $100, that goes up $100. This goes up by $200, that goes up by $200. And the increase would be the marginal cost. So for right here, if total cost is $4,000 when output is 10, and total cost is $4,300 when output is 11, what's the marginal cost of the 11th unit of output? Very simply, what did it do? Total cost, it went up by 3,000. Sorry, it went up by 300. So the marginal cost for the 11th unit would be $300. Marginal cost also falls at first, it's a minimum point, and then will increase. We talked about increasing margin returns on the previous lecture on production. Well, they also play here. Understand that our cost numbers are all influenced by what happens with production. These are simply dollar numbers applied to our production numbers. So we have increasing margin returns. Again, as more and more of a variable input is added to the production process, holding at least one input constant, and that would be capital, the resulting increments of production, marginal product, will many times increase. What this tells us that is if the marginal product is increasing, which is increasing margin returns, the marginal cost is decreasing. Think about it down here. Let's say the marginal product of the 10th worker is, say, 100 bagels in a bakery. And then the 11th worker has a marginal product of 200 bagels. And let's say the wage per each worker is $15 per hour. And let's say this is for the day. So we take an day times by 15. So the daily is 120. So then they want to see what is the cost per each of these bagels. Well, at $120 for an 8-hour shift, worker number 10 brings in 100 bagels. You divide $120 by 100 bagels, you get $1.20 per each bagel. So when we hire the 10th worker, each of those bagels will cost us $1.20 in terms of labor cost. Okay, talked about bagels. I take care of my cat. And then we hire the 11th worker, brings in 200 bagels now, which is twice as much as before. The cost is the same for that 8-hour day. We divide the cost of that worker by how many bagels that worker adds in to production. We cut the cost per bagel in half. Instead of costing us $1.20 per each bagel, it now costs us 60 cents. So you can see when the marginal product goes up from the 10th to 11th worker, it drives down the cost per bagel, the marginal cost. So marginal product going up. The additional cost of each one of those bagels is now 60 cents, where it used to be $1.20. Then we come across diminishing margin returns. And again, that is where as more and more of a bagel is added to the production process, holding at least one of their input constant, capital, the resulting increments of production margin product after some point will diminish. So we go here, we find that means when the margin product is decreasing, it's going to be driving up the marginal cost. Go back to our bagels. We had the 11th worker was bringing in 200 bagels, and that was 60 cents per each bagel. But now the 12th worker brings in a little bit less, say 180, because now we have diminishing margin returns. The 12th worker has less capital to work with than the 11th worker. Wage is still the same. The daily cost is still 120, but now we're taking the same 120 divided by a lower increase in production. So then my cost per each of these bagels has gone up from 60 cents to 67 cents. So by having the marginal product go down, which is right here, it's going to be driving up my additional cost per bagel from 60 cents to 67 cents. Next thing to do is put it all together in a table and see how all the things are connected. And I'll do that in part 2.